So as we've already mentioned, a molecule is going to be two or more elements bound together. A compound is a molecule that's made up of at least two different types of atoms. I am not going to expect you to remember the difference, but your textbook does differentiate between molecules and compounds. A molecule is just any group of two or more atoms bound together. A compound must have at least two different types of atoms. Great example of this would be water, H2O2, H2O2, hydrogen peroxide, carbon dioxide, sodium chloride. These are all, here, let me get my pointer again. These are each compounds. They are made up of multiple types of atoms. Oxygen, on the other hand, and hydrogen gas are only going to be what's known as, they're molecules. They're made up of two atoms bound together. They are not technically compounds because they are not made up of different types of atoms. I am not going to be particular in this class. You can use molecule or compound interchangeably. Doesn't matter to me. It's kind of like how all squares are rectangles, but not all rectangles are squares. All compounds are molecules, not all molecules are compounds. But the atoms that are found in a compound are going to be held together by energy bonds, or they're going to be held together by those chemical bonds. Electrons possess energy, as do the bonds between those atoms. And organisms are going to be directly dependent on chemical bond energy in order to maintain their organization. And as we're going to learn later this semester, organisms are going to routinely break down glucose in order to obtain energy. They're going to take this large molecule over here, C6H12O6, which is the molecular formula glucose. They're going to break it down, and they're going to use the energy they get from breaking those bonds in order to allow life processes to happen. And so the bonds that exist between molecules contain energy, and these are caused by interactions between the electrons in the outermost shells. And the process of bond formation is what's known as a chemical reaction. So these bond formations, these chemical reactions, are going to occur by either the loss, gain, and or the sharing of valence electrons. So all bond formation comes down to the interactions of those electrons that are going to be found in the outermost shell, that valence shell. And there are a couple of different kinds of bonds that we're going to talk about. There's ionic bonds, covalent bonds, and hydrogen bonds. And we're going to spend a little bit of time focusing on each one of these. Ions. An ion is an atom that has lost or gained an electron, so it no longer has a neutral charge. Remember when we talked about carbon? And we talked about, for example, let's take a look at carbon. Let me back up to our periodic table. Carbon has an atomic mass of 12. Has an atomic number of 6. So an electrically neutral atom of carbon should have how many electrons? An electrically neutral carbon atom should have 6 electrons. Because an atom of carbon has 6 protons, or 6 positive charges inside the nucleus, it needs 6 negative charges orbiting around the nucleus in order to balance it out. What would happen if we suddenly lost an electron? Would the atom become positively or negatively charged? The atom is going to become positively charged. Remember that electrons have a negative charge. If you lose a negative charge, you're suddenly going to have 6 positive charges in the nucleus, 6 protons in the nucleus, and only 5 negative charges floating around on the outside in those electrons. So if we have 6 positive charges, 5 negative charges, we have an overall positive charge. But ions can go both ways. Ions can carry either a positive charge or a negative charge. If they lose an electron, they become positive. If they gain an electron, they become more negative. And this can happen, this change or this loss or gain of electron can be caused from atoms donating or accepting electrons. So a great example of this is going to be sodium chloride. What happens is that we form an electric bond based on the mutual attraction of oppositely charged ions. And we'll walk through the process of what this looks like. But if we have an ion that suddenly gains an electron, they're going to have a negative charge. If we have an ion that suddenly loses an electron, they're going to have a positive charge. And that attraction between a positively charged ion and a negatively charged ion is what's known as an ionic bond. And like I said, we're going to walk through a great example of this with sodium and chloride. So here we're going to take a moment and we're going to look at our different molecules. Sodium is going to be found right over here on the periodic table. So here we have sodium. Sodium has a charge, has an atomic mass of 23 and has an atomic number of 11. So if we were to draw an ion of sodium right now, how many positive charges would you put inside of the nucleus? All right, we have 11 protons hanging out inside the nucleus. If we're going to have an electrically neutral atom, how many electrons are going to be found in the next energy shell? 2. Remember that we're always going to have only 2 electrons in that first energy shell, 8 electrons in each shell after that. All right, so we have 11 positive charges, or 11 protons in the nucleus. We have 11 negative charges, or 11 electrons, orbiting around the outside of the nucleus. What is that molecule going to look like? So here we go. I'm going to move ahead. Here we have our sodium ion. We have 11 positive charges here. We have 11 negative charges around the outside. Here we have 1, 2 in our first energy shell, 3, 4, 5, 6, 7, 8, 9, 10, our total, or 8 in our second shell for a grand total of 10. And then we've got our 11th electron right out here on our outermost shell, known as our valence shell. This is going to be our valence shell. Now, is the is the atom happy having 1 electron in his outermost shell? No, he wants to have a full octet. He wants to have 8 electrons in his energy shell. Now, is it going to be easier for him to get rid of that 1 electron so he can bump down and have 8 in his outermost shell, or is he going to pick up 7 electrons? Well, we're going to find it's a lot easier to get rid of 1 electron than it is to pick up 7 more. So what sodium's going to do is he's going to kick off this extra little electron, get rid of it, and he's suddenly going to become an 11 proton nucleus. So sodium still has 11 protons in the nucleus, but he only has 10 electrons orbiting the outside. What is his overall charge? If he has 11 positive charges and 10 negative charges, he's going to have an overall charge of +1. That's indicated over here. So here's our sodium with a positive charge. Chlorine, on the other hand, chlorine is going to be found over here. Chlorine has how many electrons in his valence shell? And this time we're going to take the cheating route and we're going to just look real quick at what group he is in. Chlorine is found in group 7. That must mean he has 11 electrons in his outermost valence shell. 1, 2, 3, 4, 5, 6, 7. And if you take the time to draw chlorine out, you will find that he has 7 electrons in his outermost valence shell. Now, it's going to be easier for him to get rid of 7 electrons or pick up 1 electron. We're going to find it's a lot easier to pick 1 up than drop 7 off. So what he's going to do is pick up an electron. Now, if chlorine suddenly picks up an extra electron, he goes from having 17 positive charges, because remember his atomic number is 17 positive charges inside of his nucleus, and then he picks up, and he's got 17 negative charges floating around the outside. But if he picks up 1 more negative charge, what is his overall charge going to be? If we have 17 positive and 18 negative, we're going to end up with 1 negative charge. So what's going to happen in the case of sodium and chlorine? Sodium is going to say, hey, I have 1 too many negative charges. I want to get rid of that so I can be happy. He's going to get rid of it. He's going to give away his electron. Chlorine's going to be like, hey, I have 1 too few electrons. I need another. He's going to pick that 1 up from sodium. Now we have a positively charged sodium atom and a negatively charged chlorine atom. What they're going to find is, just like magnets, opposites attract. A positively charged ion is going to have an attraction and an affinity for a negatively charged ion. So we're going to find that they have a mutual bond together. There's an attraction between sodium ions and chlorine ions, or chloride ions. They're going to bond together in what is known as an ionic bond. There are other types of bonds that don't involve the giving up or donating of electrons. In this case, we're going to find that covalent bonds. Covalent bonds are formed when two atoms share electrons so that each atom has an octet of electrons in their outermost shell. Those electron shells are going to overlap. The electrons are going to orbit around both atoms. This is what's known as a covalent bond. And there are several types of covalent bonds. There's single bonds where they share one pair of electrons. Great example of this would be two hydrogen atoms bonded together. Or a double bond where we share two pairs of electrons. There can even be a triple bond where we share three pairs of electrons. And we're going to start off by taking a look at how these bonds can form. We're going to look at an example of methane. We're going to look at carbon bonded to 4 hydrogen atoms. So we're going to start off by looking at carbon. How many electrons does carbon have in his valence shell? Remember, carbon is a group 4 atom. He is going to have 4 electrons in his valence shell. How many electrons does he need to be satisfied? That's right, he needs a grand total of 8 electrons to be satisfied. That's a lot to pick up. It's a lot to pick up. Picking up 4 electrons or dropping off 4 electrons is a lot of work. It's not as easy as picking up 1. What we're going to find is that atoms over here in group 1 have a great tendency to form bonds with atoms over here in group 7. They have a tendency to form ionic bonds. Atoms closer towards the middle, they're going to more likely to form covalent bonds. So here's what we're going to see. Our carbon atom right here, he's got 4 electrons in his valence shell. Hydrogen atoms only have 1 electron in their valence shell. Remember, hydrogen is a group 1 atom. He only has 1 electron. How many atoms does hydrogen need to be happy? He actually only needs 2 electrons. Because he only has 1 energy shell, he only needs 2 electrons to be happy. Carbon, on the other hand, he needs 8 electrons to be happy. So what we're going to do is we're going to share. Carbon says to this hydrogen here, I will share this electron with you if you share this electron with me. And then he goes to the next one and he says, I will give you this electron if you give me that electron. And what they do is share. These electrons are going to orbit both around hydrogen and then both around carbon, then both around hydrogen, then both around carbon. So part of the time carbon gets to have all of his electrons and part of the time he doesn't have any, but he still prefers that to have all or none than to have a partially filled orbital. The same is going to go over here. These electrons are going to form, they're going to orbit partially around this hydrogen and partially around carbon, and then partially around hydrogen, then partially around carbon, partially around hydrogen, then partially around carbon. And we're going to continue to do this, where we're sharing our electrons back and forth across all of our electrons. So that's an example of a single bond. A double bond is formed much the same way, but in this case, we're going to be sharing 2 pairs of electrons. In the case of oxygen, oxygen has 1, 2, 3, 4, 5, 6 electrons in its valence shell. He needs 8. Carbon still has only 1, 2, 3, 4 electrons in his valence shell. He still needs 8. So carbon is going to go to oxygen and say, hey, I will give you 4 electrons if you give me 4 electrons, or if you share with me. So carbon is going to share 2 of his electrons with oxygen, and oxygen is going to share 2 electrons with carbon, and we're going to get a grand total of 8. So now if we look over here, we have 1, 2, 3, 4, 5, 6, 7, 8 orbiting oxygen, and 1, 2, 3, 4, 5, 6, 7, 8 electrons orbiting carbon. And so this is how carbon dioxide is formed. It's formed by forming two double bonds with two different oxygen molecules, sharing two pairs of electrons. Same goes for a triple bond. A triple bond is simply the sharing of three pairs of electrons. Next up, we're going to be discussing polar and nonpolar covalent bonds.